All right, let's take a look at exercise 1806, question 9L. By the way, I've got the window open as I normally do, but it's a bit windy outside and stormy, so we may get a few gale-like sounds. Okay, so this one relies on a few interesting skills. The first skill, to simplify this, is to know that something to the power of a half is a square root. So I'll just talk that through first, and then I may end up making an extra video to do with this. We'll see how we go. So if, for example, if I had 100 to the power of a half, that's going to equal 10. If I had an 81 to the power of a half, well, a square root of 81 is 9. So in other words, the power of a half means the square root. So I could rewrite this one here as 100, and I could put a square root sign in front of it, and of course that equals 10. So anything with to the power of a half, or where the root of the indice, the root of the exponent is a half, or a 2 there, sorry, then that's the root or the square root. And of course we can write 100, the square root of 100, also like that. That means the second root of 100, or the square root of 100. The other thing which is quite useful, and we've got this rather interesting number here, the 5 on the bottom. Now, let's say, for example, at some point in this equation, I end up with something like 5 divided by 5. Now, we know that 5 divided by 5 is 1. Anything divided by itself is 1. In other words, we're asking the question, how many 5s are there in 5? Well, another way, of course, of looking at this is to say, well, the number on top is to the power of 1. The number on the bottom is to the power of 1, which meant if I was to put those two next to each other with a multiplication sign between, this would be 5 to the power of 1. And this would be times, well, this is going to be a negative 1 because it's 1 over. So that's 5 to the negative 1. And of course, we add the powers, don't we? So if we're not multiplying with the same base, we add the powers. Well, 1 plus negative 1 is 0. This would be 5 to the power of 0. And of course, anything to the power of 0, except 0, is going to be 1. So that is going to equal 1, and that's why. So another way of thinking about this is if I am going to be dividing this, I can actually just say, well, I've got a 5 to the power of 1, and, 5 to the power of 1, that's a positive 1 because it's a 5 on top. And let's say I've got the 5 underneath. If I want to divide that, because I know that's a 1 there, I could just cross this out and put a negative 1 there. In other words, I've taken the 5 there, it becomes a negative 1 if I put it on top. But because I'm leaving the base the same, I can just go 5 to the power of 1 and then minus 1 to represent the 5 on the bottom. On the other hand, for example, if I had, let's say something different, 2 to the power of 1, or let's make it different, let's make it 2 to the power of 4 over, let's go 2 on the bottom. Well, I could get rid of that 2 on the bottom because that's going to be a 2 to the 1. We don't write to the power of 1 if it's just a 2. But I could cross that out and put minus 1 here, which means, of course, it's now 2 to the power of 3, which, of course, is going to be 8. So this is the way we treat powers, where we have indices on the bottom, the denominator, under the vinculum. Okay, so let's have a look at this one over here now. And in the next video, I will solve that using these techniques here.